A discrete probability distribution function, or PDF, has two characteristics. The probabilities are between 0 and 1, or can equal 0 or 1, and the sum of the probabilities is equal to 1. So let's look at this example. We have a random variable that can take on values 10 up to 14, and we have associated probabilities there, except for 12, and we want to determine what that probability is. So we want to remember that the sum of that probability column needs to equal 1. Okay, so if we add up the probabilities that are given, we get 0.2 plus 0.3 plus 0.1 plus 0.2, and that gives us a 0.8. All right, so the probability that x equals 12 is going to be 1 minus 0.8. And we get probability of 0.2. Okay, now we've got probabilities for each of the values that x takes on. Let's find these probabilities. What's the probability that x is less than or equal to 12? So that's going to be the probability that x equals 10 plus the probability that x equals 11. And 12 is included in that, so probability that x equals 12. So adding those together, we get 0.7. Okay, let's get one more. We want the probability that x is greater than 12. All right, now this one is simple enough. We could just add up the probability that x is 13 plus the probability that x is 14. But let's just use something that we learned in the last chapter. We see that x greater than 12 is the complement of the one we just did previously. So remembering that when we're finding the probability of a complement, we can take the total probability of 1 and subtract off the probability of the event. So this would be 1 minus the probability of x less than or equal to 12. So 1 minus 0.7, and we get 0.3. Okay, now let's consider the probability that x equals 15. Well, 15 doesn't show up on that table at all, so there's 0 probability associated. But for the next one, probability that x is less than 15, all the values that x takes on are less than 15, so that probability is 1, or 100%. All right, x less than 11 or greater than or equal to 13. Well, less than 11 isn't going to include the 10, or it doesn't include 11, so it's just the probability that x is equal to 10. And then we want x greater than or equal to 13. So we want probability that x is equal to 13. So that's 0.1 plus the probability that x is equal to 14. So we get a total of 0.5. I guess I should back up and say, remember that we're having this OR event, so that means we're going to add probabilities. And we have events that are mutually exclusive, right? We can't have a value, we can't have the random variable equal 10 and 13 at the same time. So there's no overlap or no and probability to subtract from those. Okay, let's do some practice in creating a PDF table and also defining a random variable. So I need to add one piece of information to this scenario, and it is that we are considering buying 4 raffle tickets. Okay, so local Kiwanis Club is hosting a 200 raffle ticket sale where the grand prize winner gets $7,000. Each ticket costs $50. Identify what the random variable would be measuring in this scenario. Okay, so if we buy 4 tickets, we're interested to know, well, what are the possible outcomes for me as far as my winnings and losses, and then I want the probability that those are going to occur. So the x, the random variable here, is either the gain by winning the raffle or what is lost. All right, so if we create this table, all right, we know that we have to have a column for x and the probability of x. Now I'm putting another column in here, and this is not required, but sometimes it's helpful to think about what the outcome is and then associate a value of x to it. So the outcomes for this is that we can either win or we can lose. So if we win, all right, we got to think about, well, what are we going to gain? Well, we gain the 7,000, but remember we had to buy the 4 tickets and they're each $50. So we have to subtract $200 from that winning of 7,000. So if we win, X is equal to 6,800. And the probability that that occurs is, well, they're selling 200 tickets and just 4 were purchased. So the probability that there's a winning is 4 over 200. All right, which is 0.02. Okay, let's look at the outcome of lose. Well, if we lose, there's no winnings. We are just out the $200, so we get minus 200. And the probability of that occurring is 96 over 200, or 0.98. Okay, so that gives us the PDF for this scenario. And this random variable that is measuring our gain or loss to playing this raffle. Another example, a company makes electronic gadgets. 1 out of every 50 gadgets is faulty, but the company doesn't know which ones are faulty until a buyer complains. Suppose the company makes a $3 profit on the sale of any working gadget, but suffers a loss of 80 for every faulty gadget because they have to repair the unit. Identify what the random variable would be measuring in this scenario and create a PDF table. All right, so the random variable, we want to just think, okay, that's going to be X, and it's measuring kind of over time the gain or loss of this gadget company. All right, so we got our X values, our probability values, and then we can also think about what the outcomes are. So outcomes is we've got a faulty product, or we have got a non-faulty. Okay, if it's faulty, the company loses $80. And if it is not faulty, they gain $3. And the probability that it is faulty, well, it says 1 out of every 50, so it's 1 over 50. And the probability that it's not faulty is going to be then 49 out of 50. Okay, so there's the PDF. All right, let's look at this next one. Sally has a spinner game. Here are the rules. The player pays $2 and spins the spinner. If the spinner lands on the purple, the player wins 50 cents. If the spinner lands on yellow, the player wins $5. If the spinner lands on blue, the player wins $1. If the spinner lands on red, the player wins nothing. And we're assuming that each of the pieces of the circle, those pie-like pieces, are all the same size. All right, so let's create the table. So I'm going to put in an outcome column, and then we have values of X, and then the associated probabilities. Okay, so if we spin the spinner, there's 4 different colors that we could land on. We could land on purple, red, blue, or yellow. Okay, so let's look at what value of X is for each of those. Well, it says if we land on purple, the winning is 50 cents. Well, we have to pay the $2 to even play, so it's 0.5 minus 2. So it's a negative 150. All right, and let's just go ahead and look at the probability of landing on purple. Well, 2 out of the 8 are purple, so you get 2 over 8, or 0.25. All right, so red. Red says we the player will nothing. Player wins nothing, so that's just a -2. And there's only one of those, so that's 1/8, or 0.125. All right, if the player lands on blue, the player wins $1, so gain 1, but they were out 2, so we get a -1. And there are 3 blues, so 3/8 or 0.375. And then finally yellow, the player wins $5, so 5 minus 2. Finally have a positive outcome, positive value for x, and we get x equal to 3. There are 2 of those pieces that are yellow, so that's probability of 0.25.